Well, hello and welcome to the next episode of 3Din30. Today we're talking about building trust in metal 3D printing or additive manufacturing. 3Din30 is Velo3D's LinkedIn Live and YouTube Live channel. We host this every 2 weeks or so as we dive into the trade season. It may depend. So follow Velo3D on LinkedIn and make sure you're getting the latest show schedule. You know, hopefully my voice holds up here. I'm hearing that I'm getting a little bit of robotic. Let me know if something's going on the audio channel. I'll switch it over. Let us know in the comments. Speaking about that, this is a live session. We'd love to hear from you. We'd love to get your questions. So if you've got some questions for us, don't hesitate. I do want to start this by kind of setting the tone. Today, only about 1-2% of the total manufacturing market is derived from 3D printing or additive manufacturing. With all the hype around part consolidation, increased performance, faster time to market, it seems like there should be more. In fact, if you look at Lux Research, they say that 3D printing will be a key element in the future of manufacturing, thanks to the benefits that it can bring over other conventional methods. All right, I'm going to switch over my audio. I'm getting comments that it is not great. And we're going to try that out. How are we sounding now? Any better? Okay, perfect. We'll go low tech and actually use the computer audio today. So, you know, we're talking about the growth of this market, and Lux Research talking about 3D printing or additive manufacturing being a key to the future manufacturing landscape. And if you look at specific markets like high value metal parts markets, and that's really where Velo3D competes, this potential versus actual dynamic is even more obvious. The parts where we add value tend to be used in the highest performance, most mission critical applications. If we push the needle there, it opens up a lot of lucrative business opportunities. So the problem is that in spite of those performance gains, mission critical applications are also obviously highly risk averse. So engineers don't use parts that they don't trust. You've probably heard us say that before. So building trust is step one in realizing any of those performance and time to market gains. So how do we do that? How do we build that trust? That's what we're going to talk about today. Helping us understand more about trust in metal additive manufacturing is Laura Ely, Program Director for the Barnes Global Advisors. How are you doing today, Laura?
I'm wonderful. Thank you.
All right, hopefully the audio is going to stick with us here.
Yeah, you sound good.
All right, you sound good, so I think we're going to roll forward. So tell us a little bit about yourself. Give us some of your background.
So I have been in manufacturing for 17 years now. I love the understanding how to make things, and I started off, fell in love with molten metal at a science camp when I was in high school, and decided to become a metallurgical engineer. And then that launched me into really kind of an MMP, materials and process kind of career. I worked at a copper and brass rolling mill and then moved to GCAN Aerospace, where I got to go on more of a technology journey. I first started with friction stir welding of integrally stiffened wing skins. It's a mouthful. And that put me on the global technology stage for GKN, and it created the opportunity for me to be additive manufacturing person #1 in North America back in 2014. I stood up a team of engineers, and we scoped out all of the capital equipment for laser wire directed energy deposition for titanium aerostructures. We signed an $18 million creative with Oak Ridge National Labs, and I really officially started my full additive journey. After that, I was promoted to head of technology for the North America division. So I got to touch composites and metallic honeycomb, machining, spin forming, and other advanced manufacturing processes. And then 3 years ago, I joined the Barnes Global Advisors. So I always joke that if John Barnes asks to have a coffee with you, you just better look out. You might have a career change coming in the next 6 months. So I operate as John's right hand for running the business and obviously running programs. And I just love operating at that intersection of people and technology and strategy.
Well, speaking from someone who obviously wasn't good enough, although had a coffee with John, but wasn't good enough to be picked up. I'm a little jealous, but not entirely. Velo's done pretty well for themselves, so I'm having a good ride over here.
I think so.
But you know, you mentioned being AM engineer #1. Do you mean just for the company, or is like in the US?
Just for the North America division, yeah. So in the UK as well as Sweden, there were significant both powder bed and directed energy deposition AM activities, and they really wanted to expand and do more in the North America market.
Okay, cool. And you get a plaque for that and a trophy, and
absolutely.
Cool.
Things like this, little bits of deposited titanium.
That's the additive market trophies or little coffee stand stuff.
Yes.
So we mentioned John Barnes, obviously one of the founders of the Barnes Global Advisors. So tell us a little bit about that group. What do you do over there? What does the group do in general?
Yeah, our mission is to help customers industrialize and adopt additive and advanced manufacturing. So it's as straightforward as that. We have a team of engineers with over 130 years of experience in additive, and we bring value to our customer in three main ways. We have advising, which is our consulting side of the business, training, obviously the education, and then media, where we help customers tell their stories and make the right connections within the industry.
Yeah, and I mean, we talked about this a little bit in the past. I get the consulting, I get the training. The media just seems interesting. And from a marketing background, I'm kind of curious. What's your scope in the media side?
Yeah, it's a lot of the companies that we work with. We work with large OEMs. We also work with these small, specialty manufacturers who really do not have the budget or the time to run their own marketing, social media, and even the content and just understanding the story. So we work with customers. We help them figure out what's their value proposition, who's your target audience, what is it that you're selling, how are you going to tell your story, and then making those connections. So our engineers will do things like very data-driven thought leadership pieces. We help the customer put some good data together, and then we write an article about it and get that published in a major additive manufacturing magazine.
Yeah, that's just interesting. I know just from dealing with our contract manufacturers, some of them are smaller, and the head of marketing is often the head of the company.
Right.
Yeah, not really a separate thing, and they're obviously pretty busy. So that's cool that you're doing that. You're rolling that out. So we kind of talked about the AM market. Now, in my opinion, it seems small, only being 1 to 2% of manufacturing, given the potential to maybe do more. What in your mind? Do you think it's small, or do you think it's kind of where it will be?
I think it will continue to grow, but I think it's kind of a slow and steady type of proposition. I think you can't force it. It has to be a good fit. And I think there's a couple of factors that are really pacing adoption. And you kind of alluded to this in your intro. It's often the higher risk and more difficult applications that often have the best business case. So you're always balancing that technical capability and risk with what it is that why would you even be doing it? Are you saving schedule, scope, cost? And the business case isn't always there for the less critical applications. But the other thing that I always encourage people to think about is there's two main authorities that are going to pace adoption. A certification authority, who is the final approver of AM being used in a system, and the design authority. And that would be the group that chooses to use AM to make a product in the first place. So for certification, that component needs to meet design intent and is fit for service in a system. So they are going to have that data to trust that AM can meet those system requirements. And the design authority would be in charge of qualification, which is now it meets the design intent, including the supplier and the machine and the processing. And they need to generate that data to support that certification process.
And do those always have to be two separate entities? I mean, I kind of get an idea of certification, I think some kind of legal or regulatory body, but maybe
not always. Yeah, not always. So, for example, the National Nuclear Security Administration, they do certification within their own group. And then the other end of the spectrum would be things like, commercial aerospace. So FAA will be, the certifying body for a Boeing 737 or an Airbus A320.
Okay. And I get a feeling that they're probably not aimed at the same goals. I think, the design guy, what we talk about performance, time to market, maybe even lower cost. That doesn't sound like it would be very appetizing or really drive the needle for a certification authority. Yeah,
they're all about safety and mitigating risk. So they don't really care so much of, does it save you time? Does it save you cost? They need to say, is this safe?
Very cool. And, kind of in the safe, I think, trust. And we titled this session about building trust. how would you define trust? How would you break down the challenge?
Well, it was kind of interesting, as I often go down to fundamental definitions. And when I looked up the definition of trust, it said firm belief in the reliability, truth, ability, or strength of someone or something. And I thought, that's interesting. Those are a lot of the words that come up when I start thinking about this. So it's not blind faith, right? We don't trust something without a whole lot of data and some rigor to it. And so I feel like there's a lot of trust areas that are both in business antics as well as the technical side. And I thought through, since everyone should have the 5 lists of top 5 ways we can build trust in AM. So maybe we'll dive into those a little bit. The first one is to develop a win-win business case. There's a lot of conversations around how do we build a resilient supply chain and for the defense industrial base, all of these types of things. But to get an advanced technology into production, everyone has to benefit from the process. If someone's not benefiting, at some point, the deal is basically going to fall apart. So I've seen examples where people basically have gone out for their supply chain and said, you know, we need AM suppliers, build me a field of dreams. Don't ask your supply chain to do that. It's not going to work. On top of that, they need to understand that there's a business point where they're going to actually benefit from, you know, doing all of this investment and technical bit. We know there's a minimum investment required and it takes time. So an example where we're doing a 2-way business case like this is with Neighborhood 91, where the Allegheny County Airport Authority and the state of Pennsylvania have invested about $40 million in an advanced manufacturing production campus. And part of what they're doing is they're working on building a 2-way business case with tenants to locate at that production campus. The other thing that we have is a bit of a chicken and egg scenario where the supply chain can't really afford the risk to invest. And then the OEM's like, well, I need more than a single source. My supply chain's not ready. And so when it comes to that, it kind of starts to slow down a little bit.
Cool. We can kind of pause there for 1 second. I know we've got some audience questions here. Kind of in the business case realm, right? I mean, we talk about business case, we talk about profits and revenues. And here's a great question for Bruce. Most companies don't know how to price AM when compared to other types of manufacturing. And what about business case development? Any thoughts on those subjects?
Oh, yes, many. Having gone through that process, if you think about, you know, take like a standard machine shop. So I was doing that at GKN when we said, okay, we know how to do metal manufacturing, right? And it's subtractive and you take away layers and you make up your rates and you understand the labor and you price it out and there's a nice template and they know how to do that. We said, okay, now we're going to add material. And they're like, what? Our model doesn't account for that. Okay, so we had to go back and build a completely new model as far as how you build up that pricing. This is an area where at TBGA we spend a lot of time is getting into the process economics. You can't just do it very generically because for each AM process, it does have unique considerations that actually contribute to cost. So my recommendation with this is if you're trying to build a business case is to go through the entire value chain of your manufacturing process, material all the way down to final inspection, and make sure that you're accounting for that within your business case and within your process economical models.
Yeah, and just something from more of a classical price cost idea. I mean, price and cost don't have to be correlated. There are plenty of examples where they're not. And I don't know how much that thought has gotten into metal AM. It seems like a little bit of a cost plus in my experience, and then kind of the color you just gave it feels a little bit cost plus. Is that sort of your feeling on this?
I think it can be. I think the other thing is understanding the minimum. If you're going on straight cost reduction, what's the minimum required? In aerospace, a lot of people will say, if you don't have a 25% cost reduction on your initial business case, we're not even considering it because we know there will be other things that come up and we'll never actually realize the full 25% cost reduction. So it's understanding kind of where those goalposts are for, the business that you're operating within.
Well, and I think there's another side of it too. It's not just a race to the bottom. You could also find something that creates more value for a customer and maybe you're charging more than, whatever markup you had in your business model, but that gives you then the profit and the ability to go a little bit lower on something that might open up new doors. So I think that some of these pricing models, I hope they're being used a little bit more often out there.
Yeah, I think the other thing is just this win-win business case is have an open conversation about that between customer and supplier. The more open you can be. I mean, a lot of times people are like, oh, I'm going to hold this close to my chest and I'm not going to let them know. But you can be honest, like at this point, this isn't profitable, so it's not going to work for us. It's, be a little bit more honest about it, because if you have a mutual interest in getting advanced technology into a platform, then hopefully a little bit more dialogue on the business conditions that will make both successful will actually get you there.
Yeah, no, we could definitely get down the pricing discussion, but I think that's a good one to start with, is kind of getting that win-win business case. And so that's 1 of 5. We'll keep track. So the second one.
Yeah, the next on the list is be honest and direct about your capabilities. So this has ramifications for business development as well as the investment side of things, which TVGA, we participate a lot in both of those categories. But if you're not truthful with your capabilities when you speak with a customer or an investor, you're setting yourself up for failure, because if you can't meet those objectives or those requirements that you set, I have seen way too many examples of overselling a technology that ends poorly. And there's a couple of different outcomes from that. Early failures that give AM basically a black eye. People didn't understand it failed for whatever reason. And leadership says, oh, we tried AM, it doesn't work. And they kind of brush it off. And this is where someone said, oh, it's all about data with trust. And I'm like, no, perceptions and past experiences, we're all human, right? We're not robots. It's not just data feeding in. So emotions and past experiences play a role in whether someone's going to trust a technology. So we advocate for a crawl, walk, run type of approach. Start smaller, start on something less critical, build your skills and capabilities, and then march your way up. Another example there is, equipment that's not industrially ready, or maybe they have an immature maintenance and repair network. And so once someone gets their machine, something happens and they can't get it fixed within an appropriate time frame. Machines that have a nickname like Sparky tend to, they pop up a little bit. And I think the network equipment manufacturers are absolutely maturing in this space, but we need some honesty there. And on the investor front, well, obviously, if you aren't actually able to meet those technical or those business goals, then you stand to lose a whole lot of money.
Yeah, I think the idea of starting small sounds really fair, because almost all the conversations we've had start with, well, it depends. Right. It's like, can you print this? It depends. And that's a terrible marketing slogan, right? It's not something you're going to see in the marketing collateral, but most of the time, I'd say that's probably the first answer you're going to get. And until you really get into the conversation and know the details, it's hard to know. And also roadmap items. I know for us at Velo 3D, we've had a number of parts come in, and day 0 probably couldn't print it. But 60 days, 90 days later, yeah, we're developing it, and we've got new processes and printers. So even in that case, it's like, okay, right now, can you do it? Well, let's find out. It depends. And it's like, okay, you couldn't do it today, but can you do it in 60 days? Let's find out. We got to work on it. So given where the technology is, that's probably, you just have to get your feet in the water.
Yeah. And I think the important part is just being honest. Maybe not today. We're going to work on it, and we'll be honest with you as we kind of go through the process.
Yeah. So definitely, if you're interested in getting a part printed, be ready for it depends.
Right. Absolutely. Okay.
Right, so two down.
Next on the list is protect the data. So this has a cybersecurity element to it, as well as an intellectual property element to it. So think of it as who owns what and how is it being protected. So intellectual property, I would say one of the biggest hot topics for IP ownership is the build file. So for people that aren't as experienced with AM, you have the CAD model, which is your final part. But there's several steps in between with slicing of that file, addition of sometimes support structures, orientations, things like that go into the build file. So it's a separate piece of intellectual property. And it's like, okay, who owns it? Is it the design people up here? Is it the process IP down there? So that's something where that has to be really ironed out early. Make sure you have that ironed out early in a contract to make sure that we don't have trust issues and things that come up because of that.
Well,
the others,
I imagine, well, you just mentioned kind of the supports and the orientation. I mean, stock material. If you've got material you're adding on because you're 3D printing, it wasn't any original design, you're getting feedback from the print shop that you need extra stock on something, and you're the one adding it in CAD. It sounds like this could get very confusing very fast.
Yeah, it can. Well, and even managing that data. We say protecting the data. What platform you manage it in? How do you serialize it? How do you know you're using the right build file each time? And obviously, there's a lot of software manufacturers that are helping to solve that problem. So the other side of this is the fact that additive is a digital manufacturing technology. So when you hear about Industry 4 and digital manufacturing, you're inherently opened up to more of a cybersecurity risk because your data is connected and it's more available. And so we had a very unfortunate one that I just heard of very recently, where a manufacturer that had both AM and traditional manufacturing capabilities was completely shut down with a $1 million ransom from cyber attackers. A smaller, medium business. And it's just, I feel like that's going to continue to pop up for advanced manufacturing and digital manufacturing in general. And I think we're really going to have to get programs out there that help those smaller, medium-sized manufacturers invest and get the right protection in place so that we're not getting intellectual property stolen or things like this where you've got, ransom and things like that for it.
Yeah, we do have a question. How would you compare the IP for additive manufacturing? Would that be similar to NC programming?
Yeah, I would say the build file would kind of be like the analog to the NC program. And hi, Bruce. It's good to hear from you. Yeah, absolutely. Exactly how you do that machining, how much you take off in roughing, the fixturing process, things like that. Traditionally, that has always been the manufacturer's IP. The customer defines what the end part needs to look like, maybe a forging envelope, but the manufacturer decides how do I remove the material and get to that end requirement state.
And I know from a Velo point of view, we've had, Bruce is saying hi back to you. From a Velo 3D point of view, we are trying to create like a network, a contract manufacturing network, with the idea being you take the software file, you get it printed in 3 or 4 contract manufacturers. So, I mean, that's not your most common business practice. A lot of times you get a CM and you work with them directly and they can kind of print it and the parameters are what they are. But with that distributed network, this idea of who owns the IP around your build file ends up coming up more, from what I've seen, than potentially other cases. So it's definitely something to pay attention to.
Yeah, absolutely. So
all right,
next on the list, dun, 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 is understand the qualification path. So you heard me give that description of qualification, and you've got to be thinking from that standpoint that there's a lot of details in that, as well as a lot of parties involved with it. So the entire value chain for an additive manufacturing, product is going to be engaged and have needs to fill in to meet qualification paths. So asking what performance, stability, reliability, robustness, what's the producibility that's required to qualify a component, and then also understanding what is your role. So material suppliers are going to have a role, equipment, software, the actual manufacturer, if you've got multiple manufacturers, there's all of these things that'll play up. So we need to characterize our materials and our processes. And we also need to understand how we're going to analyze material quality. So traditionally, there's kind of do a ultrasonic inspection of your billet up front and then do an NDT over the surface at the end with a dye penetrant, and you're pretty much good. Titanium example there. But the neat part is we're getting to the point of with additive processes, since we are building layer by layer, we can look at the part layer by layer. And Mike, obviously you'd speak to it better, but I know that Velo has some of those capabilities with respect to predicting and seeing in process defect detection.
Yeah, it's the layer by layer thing is critical, and being able to monitor that and track it and watch it. For a full build, you get a terabyte of data, which is about as useful as a bucket full of sand until you do something with it, right? So,
Yeah.
And that's really where the magic comes in. And I got to say, Greg Brown, he's our VP of technology or process technology, and his team has done some amazing work on being able to calculate where they believe melt pool instabilities will be or porosity will be in the bulk. And so they're looking at the downskins and predicting on the downskin where you can find issues. They're looking at the bulk and predicting where you find issues. It's pretty amazing technology what they're working.
Yeah, that's awesome. And I mean, it's just having seen powder bed technologies for the last, 10 years, it's really exciting with those as well as directed energy to just see the, progress that we're seeing. And I just see Edgar's asking, hi, Edgar. So he literally is asking the question that is the next topic for us.
Yep.
How much
we
longer?
Saved the best for last, Edgar.
Yeah. How much longer until specifying bodies beyond the aerospace will start incorporating more and more AM into industry specs? So the next item on our list was, standards, new AM standards and specifications. So standards and specifications form a foundation. And they serve quite a few purposes, but they really help companies to, it simplifies the qualification process because we have a common set of requirements. And then, companies and specific applications might layer additional needs on top of that. But I can definitely tell you, I actually ran a little service bureau for a few years as president, and having this specification from Boeing and this specification here from Northrop and a different specification from an oil and gas customer. And then you're trying to build the quality management system that, satisfies all of them. It adds cost. And that means that the customer is going to be a recipient of that cost with the, pricing being increased of having all of these specialty processes. So that's where I see as being that huge value is at least as much as possible. And it also speeds up the process because someone says, I've got an application. I already have a foundation for, say, the material and the process and how I go through that. We are seeing, obviously SAE has all of their aerospace material specs and AMSs. We are seeing movement in automotive. We're seeing movement in oil and gas. I know that oil and gas is working on that. We also have NCAMP has a checklist for additive manufacturing. So you can be AS9100 certified along with NCAMP certified, things like that. It's true for rail and heavy transport as well. I don't think they were quite as heavily on just, standards, but we're starting to see the movement. But where I get excited is how much can we lever the standards that are already there? So let's say we have an AMS spec. How much of that could be used for automotive? Because it's really talking about a material and a process and control. So while there might be some criticality differences and how things are specified, there's a whole body of knowledge that's already there that I think we can grab onto and quickly leverage into other markets.
Yeah, Bruce asked a question, what about composite validation? Could that be a template?
It's being used, yes. So the NCAMP, Bruce, you'll be excited to hear the NCAMP model out at NIAR that helped with qualifying CFRP for commercial jetliners has been used for additive. So it was used to qualify, develop the base material performance for ULTEM 9085, which is a polymer material. But that concept is still applicable for metals technologies as well. So there's a really decent analog between composites validation as well as some of these additives, because again, they are both layer-wise processes.
We've got one question, but I know we've got our last of the top 5 ways to build trusted metal AM, and I think this actually could fit really well in with this last one. So I'll let you do the last one, then we'll get to this last question.
All right. Well, I would be remiss if we didn't talk about requirements. It's all about the requirements. So it's not just about the printing requirements, though. We really have to look at the entire value chain and what the very end product requirements are. The other thing that we need to understand for is when we are looking at this, what are our business requirements? It's not just technical requirements. What do we need to optimize for? Is it schedule? Is it scope? Is it cost? If there's any project managers out there, you'll be happy to hear the triple constraint. But an example that I have of this is a group that was looking, they're really focused on solving the problems around the printing requirements. They had a business case and thought they understood the cost for a part. But later on, they realized that actually the final requirements require a very expensive computed tomography scan, and it completely blew the business case. And it basically, after they had done some of that, so they could still leverage that technical for somewhere else, but the business case for that application was done.
And I'll kind of get to Anthony's question here. Would it be fair to say that there is limited AM performance data available for stress engineers to use when designing next generation components?
Yes, the answer is yes. The good news is that there are efforts that are ongoing. So one of these is SAE ITC. I'm sorry, I'm going to give you a whole bunch of acronyms. The SAE ITC has their Additive Manufacturing Data Consortium. And this is where they are essentially crowdsourcing material data, performance data. And if people don't have pedigree data to bring in, the group and the consortium will basically pool money and pay to go generate that data. So this is what's starting to fill that gap. Metals manufacturing, you kind of like that. People want MMPDS. Sorry, got a bug. MMPDS level allowables, and additive doesn't necessarily get there easily. I think it can happen eventually, but this AMDC is like a prior step to that. And we're saying, can you just develop specification minimums, which designers can design off of that from kind of a basic. And then the next step would be, okay, let's have a handoff. Let's work with MMPDS and get MMPDS allowables that are actually democratized and people have access to them. So it's a huge barrier, but I am excited that there are efforts. There's probably other efforts within different areas that are similar to what I just described with AMDC going on as well.
Yeah, I know Will Hastings on our side is working on the MMPDS submission and trying to get that through for NCAMP 718 process. And to our knowledge, we're the first equipment supplier, to do it at that level. Mm-hmm. Which I'm pretty excited about, because that now just gives your contract manufacturing network the ability to produce metal at that known performance.
Yeah, absolutely. I mean, and Anthony had kind of the extra little bit where it is difficult to model anisotropic performance of a component. I mean, there are opportunities there with heat treatments and microstructure modifications that can help with that. But the other thing is, and I know Velo has their versions of this as well, is, again, what are you optimizing for? And if you can optimize thermal history to have a similar thermal history, whether you're in a thicker portion of the part or a thinner portion of the part, you will have less anisotropy, which is basically uneven, properties this way are different than these. Because at that point, if you can just be predictable, if you can just do the same thing each time, then you can account for that in your design or with your FEA analysis and those types of things. So I think we're getting to that point. I think industry is moving there, but it's still definitely a hurdle.
And I know our producer is giving us a post 5-minute warning. So we have gone over a little bit, but we definitely wanted to get to the questions. But kind of bringing this to a close, what are your final thoughts on this? Where are companies doing this? Are we headed in the right direction? Are we headed in the wrong direction? Do you see any big inflection points in the near future?
Yeah, I think from my standpoint, it's almost, my view is less industry specific and more application specific. What we're seeing are things like heat exchangers. They're everywhere, by the way. Fluid control type things, hydraulic systems, hydraulic manifolds, slam dunk, shrouded impellers. You've got your, hero shrouded impeller piece that you're able to do without support structures. There are awesome sweet spots of materials and processes and applications that are all over the place. So I think it is understanding and learning from those and saying, okay, how does that apply to things in another industry? The other areas that I keep an eye on is urban air mobility. not only just the battery technology, but the weight and cost needing to be controlled. People like Joby Aviation has already said that they are on a path to certify a safety critical metal AM part that was announced a couple years ago. And then other areas like hypersonic weapons. The US government is significantly investing there. So those aren't going to be high volume type applications, but again, maximizing weight and performance on those things. Heavy transport. If you're wanting to know cool stuff that's going on with transport, check out Mobility Goes Additive. This is by Stephanie Brickvidi over in Germany. She works for Deutsche Bahn as well. They've got a whole consortium that's moving stuff forward. But when I go back to reflecting on trust, building trust does not mean never failing. And I think AM is a really great vehicle actually to fail fast and then speed up the learning cycle. It pretty much interrupts our standard product life cycle, that we do lots of little iterative design circles. And to Anthony's point, hey, if you can't analyze it, test it, because you can do it quickly. You can build it, you can do a lattice structure, you can test it and be in quickly. So building trust for me is bring data, number one. Represent your capabilities honestly, and that way you communicate the level of risk and reward with your partner or your network.
Well, thanks, Laura. Some of these sessions, time just flies, and this was definitely one of those where we're definitely creeping up on 40 here. We're gonna have to rename the thing after this session. But thanks for joining us, everyone online. And Laura, could you share what's the best way for people to get in touch with you? Seems like a lot of them already are in touch with you, but what's a good way for someone who's watching this for the first time to get in touch with you?
LinkedIn network is awesome. Feel free to hit me up. I try to keep an eye on my messages. And if you want to check out more of our team, we're available at www.barnesglobaladvisors.com.
All right, and we'll put a link to that in the show notes in the comments in the bottom. So, thanks for watching, everyone. Make sure to follow the Barnes Global Advisors, follow Velo3D to get our next awesome session. We've got a couple planned up in October that we're working on. Not a final schedule yet, so stay tuned to LinkedIn to see what we're bringing. And thanks for joining us. Have a great
day.